guys. Okay, one last video for Unit 3A before you're going to be taking your last mastery check and getting ready for the test. So let's go ahead and get to it. We're going to be solving these problems using the quadratic formula, but the setup is going to be very similar to solving any of the other word problems we've done in this unit. So this time a golf ball is hit with an initial velocity of 80 feet per second, and we gave you the formula so you don't have to worry about plugging anything in as far as initial velocity and all of that stuff. Then the first thing we want to know is how high is the ball after 2 seconds? Well, remember that in this problem, t represents time. So if we want to know 2 seconds, then all we have to do is plug 2 in for that t. So we've got negative 16 times 2 squared plus 80 times 2. Really? This is just an order of operations. I need to make sure I do what's in the parentheses first, except there's nothing to be done there. Then I go to exponents. So the only thing that could really mess you up here is 1, not knowing where to start, and 2, not following those order of operations. So please, 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 2 squared is 4. And now I'm ready to move on to multiplication and division. Negative 16 times 4 is, I believe, 64, but let's just make sure. Okay, so negative 64, and 80 times 2 is 160. Okay, so then negative 64 plus 160 is going to be 96. So, and this is being measured in feet because that stands for feet per second. So the answer to part A is 96 feet. That's how far the ball will have flown after 2 seconds. Want to know is how many seconds would it take the ball to hit the ground? And this, we give you the hint this time that the height would be h equals 0. So this time we're looking for seconds. So t is going to be unknown, which means we are going to have 0 in place of h equals negative 16 t squared plus 80t. Okay, so it says that we're supposed to be solving this using the quadratic formula. So if I'm using the quadratic formula, then the first thing I want to do is look for my a, b, and c. In this case, a is negative 16, b is 80, and c, since there isn't one, is going to be 0. Okay, so let's go ahead and plug it into our quadratic formula, which, remember, you've got to have it set equal to 0, which luckily it is. So I paused the video and wrote down our quadratic formula for us so we can go ahead and start plugging in. Now, b is right here, and so I'm going to plug in 80 for b in both places. A gets plugged in 2 places, and I'm going to plug in negative 16 for that. And then c just gets plugged in 1 place, and I've got a 0 for that. So let's go ahead and get to it. Negative b means I'm going to have negative 80 plus or minus 80 squared minus 4 times negative 16 times 0 all over 2 times negative 16. Okay, so let's start simplifying that. Negative 80 inside the parentheses, 80 squared is going to be 6,400, not inside the parentheses, inside the radical. 80 squared is going to be 6,400. Over here, negative 4 times negative 16 is positive 64, but when I multiply that by 0, it goes to 0, so I don't have to worry about that. And then 2 times negative 16 is negative 32. Okay, now square root of 6,400 is 80, and I've got negative 32. So now it splits into 2 different things. I've got negative 80 plus 80 over negative 32, or I've got negative 80 minus 80 over negative 32. Negative 80 plus 80 equals 0 over negative 32 equals 0. Well, I'm looking for the time it takes the ball to hit the ground. So this goes back to kind of like that problem we did in lesson 3A-8, where the reason I got 0 as an answer is because, yes, the ball is on the ground at 0 seconds because I haven't hit it yet. So that's not what I'm looking for. So this has got to be it. Negative 80 minus 80 is going to be negative 160. And negative 160 divided by negative 32 is going to be 5. Negative divided by negative is positive, so we get 5. And that is 5 seconds. That's how long it takes the ball to hit the ground. All right, so let's go to part C. For this one, we want to know, when will the ball reach 48 feet? So instead of h being 0, h is going to equal 48. Okay, so let's go ahead and plug that in. We're going to have 48 equals negative 16 t squared plus 80t. And in order to use the quadratic formula, I need this equation to be equal to 0. So I'm going to move that, that constant over to the other side. So I'm going to subtract 48 from both sides. There's no like terms to subtract that 48, so I've just got 0 equals negative 16t squared plus 80t minus 48. Now guys, if you wanted to factor out a GCF, I'm not sure if Mr. Thomas Wick told you this or not in his video, but if you wanted to factor out a GCF here before plugging into the quadratic formula, you could. It's not going to change your solution at all. It'll make your values over here a bit smaller, which, you know, could be a good thing, but it's also an extra step here, so it's really up to you. I'm not going to bother with it right now. So I need to identify my A, B, and my C. A is negative 16, as often happens because that's the gravitational constant. B is 80, and C is negative 48. Okay, so when I plug this in, my A is going to be negative 16. I'm going to be plugging that in. Here's my B, and here's my C. So let's go ahead and plug some stuff in. I've got time equals negative 80 plus or minus 80 squared minus 4 times negative 16 times negative 48. Unfortunately, it's not going to go to 0 this time. That was pretty nice last time, wasn't it? And then 2 times negative 16. Okay, so now it's just crunching numbers, guys, as so often happens with using the quadratic formula. 80 squared is 6,400. And then minus, I'm going to pull up a calculator for this, 4 times 16 times 48 is 3,072. Let's make sure that's right. 4 times 16 times 48, yep, is 3,072. And a negative times a negative is positive, times another negative is negative, so that's why I've got that there. That calculator doesn't have the negative button, so I have to kind of think through that on my own. And then underneath, 2 times negative 16 is negative 32. Okay, next step, I'm going to do my subtraction in here. So 6,400 minus 3,072. 6,400 minus 3,072 is 3,328 over negative 32. And the square root of 3,328. I'm going to pause real quick and figure that out. Okay, I had to break out the real calculator for this one because the square root of 3,328, it is not a perfect square. It simplifies to 16 times the square root of 13. So that means now my equation is negative 80 plus or minus 16 root 13 over negative 32. So when I simplify this, what it ends up being, I divide out the 16 out of each of these pieces, I end up with 5 plus or minus the square root of 13 over 2. Now, in applications, we typically give a decimal approximation because I want an actual time. So the decimal approximation for this is going to be, according to my calculator, 0. I'm going to round to the nearest hundredth. So that's going to be 0.70 seconds. That is for 5 minus the square root of 13. 5 plus the square root of 13 is 4.30 seconds. So as with every word problem, we now have to think about which of these solutions makes sense. Which one is it that we're actually looking for? Well, it wants to know when the ball's going to reach 48 feet. So think about the trajectory of this ball. It started out, I want to get back down to my solutions here. Okay, it started out on the ground. It got hit up. At some point, it got to 48 feet after 0.7 seconds. And then after 4.3 seconds, it hit 48 again. So really, I'm not sure which one this is asking for, which solution this one wants. It hits 48 seconds for the first, 48 feet for the first time at 0.7 seconds. Hits it again at 4.3. We're probably looking for the first one, but I would give both and see what happens. You might want to ask Mr. Thomaswick or Miss Smith and see if they have a different opinion, but to me, this is probably the one we're looking for, but I'm not going to count off if you give me this one. On a worksheet, I'd give both. All right, have a great night, guys. Let us know if you have any questions.